the stakeholders don't know coding. They don't know all this Python, Java, uh, uh, C++ languages. They only want to know something that they could relate to, something that is useful to them. For example, me, that I work with so many medical experts like the urologist in the chronic kidney disease project that I did last time. They don't know all this Dogon Turanchi of coding. They are only interested in seeing things in form of graphics and also finding out what the statistics are telling them. So if I go to them showing them codes, they are not interested. They don't want to know it. They are professors of medicine, so they don't have that time to go through all these things. So what I need to do is to make sure that I communicate it in a very user-friendly. Either I put it in report, which is in the document form for them to read, or I put it into presentation, such as we go in workshops and also in conferences. Another option is to make it into web application or mobile application that they could recycle. Now, the thing is this: all these things is a way of communicating your findings to the end users, and also to make sure you bring this machine learning models that you have used to solve a particular problem to begin to solve real world problems, because that's the essence of knowledge. It's not just for you to get the knowledge and hide it. No, it's for you to get the knowledge and be able to put it into use or put it into practice. Let me tell you, one of the reasons a lot of people, and you see that in lots of, we have a lot of issues in third world countries, is because they fail to translate real world knowledge, this book knowledge to real world knowledge to solve real world problems. So you see that we have so many professors in places like Nigeria, but we do not have. You still see us struggling with basic things. You still see us having a lot of issues around, for example, traffic. When you go to Lagos, you will see people stuck. But this whole traffic, there is a smart city technologies that have been invented, that have been developed. There are digital twins that we could easily put into use that could be able to create systems that will solve this whole traffic issues in places like Lagos. But the reason why these things fails is because we do not have that translation between the computer form of knowledge or the book knowledge to solving these practical problems that are on ground. So, and that is because we failed to be able to understand how to deploy this into platforms that could be able to be solving these problems for us. So you could now understand why this topic is a very, very hot topic and is very, very important. How do you deploy these models? How do you begin to put them into production to solve these problems for you? So after you have done all the practice, you have processed the data, you have removed the missing values, performed the model tuning and evaluation, you have gotten the best model that that model has, for example, accuracy of 99%. Now, how does that 99% translate into real world application? So that's where the model deployment comes. So the model deployment will package this whole model that you have built into a machine learning format, and then it could be able to use that package in combination with some interfaces that you will produce. Then you can be able to begin to use them in form of applications, and other people can be able to use them and give you feedback. So the whole system goes back to, you don't just train it one time and leave it, because with time, once you deploy it, you may see a shift in distribution. So once there is a shift in distribution, it may begin to affect the predictions. So you don't just train it and then you said, oh, it's a one-time thing. No, it's a continuous process. So the whole cycle goes back again. You may not go back. That's why you see, we don't have to go back to the data processing phase, but the model training is a whole cycle. So we go back like this and we go back again. So it helps the stakeholders to make proper decisions that are, or informed decision, in other words. Then another thing is, when we build it with user-friendly interfaces that people could be able to use them and be able to, for example, when you logged into the website of organizations, you begin to use things like chatbot to begin to chat. But beneath that chatbot is the natural language processing that is doing all the transformation between all the text that you are imputing into the chatbot. But you don't see those mathematics going on underneath it because you will not want to see them. This will bore you. So the whole deployment phase help us to package it in such a way where we don't have to see all those things that is happening. Then another very important thing that I would also want to emphasize, and I really want this to be let's see. Good, okay. Another very important thing is there are so many platforms that we could use to do this model deployment phase that we want to. So many of them ranges from web framework like Flask and also Streamlit, which you could deploy. And like I said, it's not only Streamlit. I'll show you other platforms shortly, but we also have things like Docker that has containers where we could put these things before we upload it to platforms like AWS, Azure, and the rest. And then we could also use application programming interface APIs to do this deployment. Now, talking about the API, the API is actually a connections that help us to link computers with computer programs or softwares. So it's a system that communicates. For example, if I have a database and I need to fetch data from that particular platform, so what I'm going to do is to use a particular API to call the data. So it's like a protocol that has been established that I can be able to use it to communicate between these computer platforms. Sorry. So another very important thing that we will be talking about shortly also is like I said, it's not just one platform. So let's look at other platforms and learn. Okay, I think probably before I talk about those other platforms, let me just discuss it. Then I will show you guys other platforms other than Streamlit. So now when you train the model, you need to find a way to make the model to be in a format that you can be able to deploy. So that brings us to what we call model serialization and containerization. Now, this whole model, remember we have been using platforms of Jupyter Notebook to do our model training. Now, by the time we do that, we need to save the model in a machine recognizable format. And these machine recognizable formats are nothing but sort of binaries of zeros and ones, because the original language of the computer, of course, is the original language of the computer is zeros and ones. So let's take a look at what it means. Now, when you train this model, you save it in a format called object. It's in the format called object. Now, since it's in a format called object, you need to serialize it. Now, that serialization will be done in order for you to be able to compress them into that sort of a text files that are in machine language, that's zeros, one, shift, and other formats. Now, by the time you do that, you can be able to save it in a database, or you could save it in a memory file or something, or directory in your desktop or somewhere. Now, in order for you to do this whole serialization, you need this special Python package. The first one is Pickle, the second one is Joblib, and then the third one is HDF5. Then there is also the Docker, where we could be able to use, the Docker is a container where we could dump these files that we have already saved. But the three packages that you could use to save them, each of them has their advantage and also disadvantage. So when you are training it offline, you need to host them. So in order for you to do that, you need now again, there are two ways you could train your model. Either you train them using your inbuilt memory, that's the CPU, or you use the GPU, the graphical interface that you need to put it on sort of a cloud that you could be able to help to do that. Now, if you do not have a high capacity computer like Linux or Mac, likely you will run out of memory when you are training data set that are very large. So in that kind of situation, you will need to get more memory. So you could either transfer it to cloud, or you could be able to just get your GPUs. Now, just like how we have CPU, I don't know if you remember the days where computers were just coming up, the desktop, and then you have this CPU out there, not when laptop was not really common. And even in offices, you still see the CPUs built. So it's the same way, but the GPUs are much, much smaller. And then most of the time they are, we have them in form of cores or something. So it's really, really like help to speed up the process because it has a lot of memory capacity. Now, should in case you do not have your large computers can fail, you need to now put them on a cloud platforms like AWS or Amazon. And I pray we will have time to look at big data so we could see how does cloud stuff work and see how do you host this scripts on cloud and how do you run your jobs or submit your jobs, and then it runs and then you'll be able to get to see the results. So the Docker helps us to be able to put these serialized scripts that we have trained and other scripts that we have created in the course of the training or data set. It could help us to put them in a container. Now, one of the advantage of the containers are the fact that if I'm transferring files to someone in another system, because we do not use the same environment, most of the time it gets broken. So in order for it not to get broken, you put it in a Docker file. Now that Docker format helps to keep it intact such that when that person is running it in his own platform, it will look like it was done in his own platform or in his own environment, even though you have different environment, because there will be conflict conflict in the packages whenever you are training in different platforms. Now, because sometimes you can imagine somebody using Linux, another person is using MacBook, and someone is using Windows. So by the time you are transferring files around them, you will likely have issues because the platforms are completely not, the environments are not the same. So the Docker helps to keep it in such a way when you transfer it to the next person, you'll be able to use it correctly. Now, let me give you an example of these things in real life. Just like when somebody goes to China and order a particular, let's say, goose, the Igbo people will like this. You order a particular goose. Now, when you order a particular goose, the goose doesn't arrive in Nigeria, in that whole format that you get it. They put it in what we call a container. That's why you hear Igbo people tell you my container, my container. They practically speak about their containers. Now, that's the same way that these things do. So all the goods you will buy, the different varieties of the goods that the Igbo people, somebody is likely, if the person is selling shoes, it's not one category of shoes they will buy. They will buy different kinds of shoes. But all of them, they will likely put them in one container. And then when they arrive in Nigeria, they will now decontainerize them. They will open them and then they would, begin to reshuffle and shuffle these goods before they take them from the depot to the final destination. So it's the same way you do when you are using the container. Because you now that produce the goods, you produce it in a different environment, but you need it to function in another environment. So the Docker helps you to do that, so it could be able to function effectively in those environments. Now, talking about the Pickle file, like I said, the Pickle package is a Python package that helps you to, translate this Python objects to a sort of a serialized object that has binaries of 0 and 1, that you could easily save them and you could load them to reuse them for later usage. Now, when I talk about the Pickle, you import it just like we do the other package importation in Python, where you import whatsoever. So you could import Pickle as PK most of the time, because that's the short form we like calling it. We say import Pickle as PK. Then you now go about to do the model. Now, when you have trained the model, we'll see that shortly during the hands-on section. You need to now open it in a particular, you write it in a particular directory. Well, now, when you write it, it's sort of like you're dumping it in that directory or saving it in that directory. Once you save it, later on, you could be able to call it back or load the model. So you have you have it in a format called NumPy array. And I think we talked about the NumPy in the beginning of the class, where I was telling you guys about data frame, dictionary, NumPy, and all that. So what the Pickle does is saves the model in that NumPy array format. So whenever you calls it, you could be able to use it. But however, the major disadvantage of the Pickle is that it is in a serialized format. Sorry, I said serialized. It works on a very small object, Python object. Like, if the model is not really heavy, it's very light, then the Pickle, it makes sense. For example, if I'm having something like very fewer features, probably 2 to 3 features that I use, and then the data set is not just that much, I wouldn't expect the model to be really that big. So by the time I'm saving, it makes sense if I should use the Pickle to do that. So if you have a very small Python object, the Pickle makes sense. And also, during prediction, if I'm making prediction based on like a one-time basis, like one object at one sample at a time, it makes sense for me to use like the Pickle. So if you are dealing with small object, the Pickle makes sense. You could always save the model, in the format. But once you are dealing with large object, the Pickle doesn't really make sense. And it doesn't mean that it cannot work on the large object. It's just that it will take time, because it needs to remember, these are machine readable format. So it needs to like look through each of them to call them back. So when it's very dense, it will take time to load. So that's what we mean by it handles small objects better. So what do we now do to overcome that kind of issues? That now gives back to the Joblib serialization. So the Joblib is also a Python package that works very well on sklearn models that we have trained. Remember the sklearn model? Most of the sklearn algorithm, the sklearn it's a very popular platform, of course, for machine learning algorithms, both supervised, unsupervised, and so on and so forth. It's do very well on them, ranging from regression, ranging from logistic regression, support vector, random forest, decision trees. All those ones are in the sklearn model. But things like XGBoost, I don't think XGBoost is in sklearn. I think it has its own package, standalone package. And then also the deep neural networks are not sklearn. They have their own package. But all the other traditional machine learning algorithms, you can always use the sklearn algorithm package to call them. So the Joblib handle this large storage of NumPy arrays, especially from the sklearn model. So when you are saving using the sklearn, using the Joblib, it handles it very well, and you can, when you load them, it's very, very effective. So in order for you to do that, you import the Joblib. I think we call, most of the time we said import Joblib as JB or something. Yeah, I think that's one of the popular format we call it, but usually the model will be model.joblib. That's how you save the model, and then when you want to load it, you can always load the model as well. So having said that about the Joblib, the next package or module that we talk about is the hierarchical data format, or the HDF5. Now, the reason is when we are dealing with large data set or data format, so that the deep neural networks algorithms, most of the time they will produce a very large, dense model. And when you talk about the neural networks, they have these different layers. And I think I could show you guys about the neural network. Let me see if I could. Good. Yes. So sorry, I used to load a lots of things, and sometimes I do a lot of things at the same time, so I can easily forget. So this is how the neural network architecture looks like. Now the NNSVG, it helps you when you want to produce publication ready neural network architectures. Okay, so you could see different of them like AlexNet. You could see the styles, and then from there you could be able to, you can play around with them. You could also load the layers you want, anything you want to do with it. You could build them. You could see this format here, and if you see some publications, you must have seen things like this. So you can build the architectures from here. You could increase them anyhow you want, the max pool, the dense, and all that. And if you want the normal convolutional neural networks, you could also do that from here. You could see each layers, you could see them, and all that. You could play around with them. You can make it shallow. You can make it deep. Increase it sometimes 24, stuff like that. So you could put, if you're interested in this, I could put it on the chat for you to play with, and all that. So what I wanted to show you guys now, no, before we go to the hands-on section, great. Let's go back to the slide. Great. So this is why the hierarchical data format makes sense, because if you look at this figure, you could actually see they are in sort of a hierarchy. You could see the connections, when you move from one layer to the other. Now, so you could imagine when you're dealing with a very complex model, these layers could even go to up to 20 layers, or it depends on how deep you want it, because this is actually a very shallow architecture. So if you're building a very complex architecture, you're likely going to go deeper. You stacks them, as you build it. So this crazy whole thing is more like when you look at it now, you could see it's more like a tree structure, like a hierarchy, and each of the layers you put will have its own parameters. So that whole building that looks more like a hierarchy, that we're building, we cannot be able to capture it using the Joblib coming from the sklearn sort of models. But instead, when we get to neural networks, I could tell you guys about things like the packages we use for the neural networks training, like TensorFlow, Keras, which are the packages we use. So these deep learning models are very, very data demanding. They are very heavy. The computations with them, most of the time, you cannot use your normal computers to do the computation because it's quite heavy. So you will require things like GPUs or cloud for them. Although when the architectures are very shallow, I don't know, I think going back to this, you'll be able to do that, when you're dealing with maybe a very small layer like this, but in any format you're dealing with, it's always going to be, quite memory heavy. So most of the time, you need to save the model. By the time you finish all the training, even the deep neural networks, we take the same format where we do 80% training, 20% testing. You will still see we maintain that the same whole approach we are using. But you could see that in the neural networks or the deep learning, most times you do things like images. You do things, images or text. So because of that, it comes in a lot of metadata and all that. So most of the time, these things will be very, very heavy because imagine if you are looking at X-ray file images, you could imagine how demanding only the data set itself could be, not talk of just the modeling. So you mostly can't save it in your normal computers. You have to just put it on the cloud. So, but once you finish training the model, you have tuned the model, you have got the best parameters, you'll be able to save them in model.h5. And then when you are calling or loading the model, it's keras.models.load, and then the model itself, you call it back to use it in your app. Now, talking about, remember I briefly introduced you guys to containerization, and I told you guys that when you are deploying it into production, because you create the model in a different environment, it do make sense if you put it in a very nice environment, or what will I say, that another person can reuse it. So the fact that I use a Windows shouldn't stop somebody that is using a Linux or a MacBook from reusing my model. So the containerization makes sense because it helps to dump this serialized models that you have and other files into a container, and then the other person can use that container without having broken packages, because most of the time the packages breaks. Recently, we have been working on this antibody pairing tasks with one of my colleagues at PeckBright Institute. So by the time I finished doing the model training testing, we were to build a web application that will help them in the lab to be able to recognize strong pairs. So when we did that, I needed to give the bioinformatician in their lab the scripts to rerun it at their end so that they could be able to see if those things are running well to what their expectation. But I noticed there was this back and forth we have to go because of the fact that the package conflict was giving us issues. So once I sent the scripts to her, it's running in my own system, but once she runs it in her end, she gets errors. So we were this back and forth, and we had to hold a lot of meetings to solve it. But if we were using some sort of Docker or containers, we wouldn't have that issue, because the moment I put everything in a container format and send it to her, she will run it on that container platform. So the container will still be thinking, when you're running it, it will feel it's running in my environment that I do the original training testing. So she wouldn't have had issues of having to, do those things, get the package and everything from start. So that's what it does. It saves you that stress of having to go through the rigor, because almost like the person would have to reproduce exactly the environment you have in order for the models to run. So instead of doing that, you would put them in a container, and then all the dependencies, all the system libraries, all the codes that you use, dump them, into this Docker file and Docker images and all that, and then once you send it, put them in that container, the other person can be able to run it. Because why you use it is because it's consistent across machines. Like I said, any other person can use it in their own machine, irrespective of the kind of machines they have. Linux, MacBook, Windows, it's fine. Then it's also easy for them to deploy it in platforms like cloud, AWS, and the rest, because everything now is in one place. You just put them upload them straight. And also it helps to simplify collaboration. You could imagine that time that we went back and forth trying to resolve these conflict packages, we could have used it for other things that are much more fruitful. Then it's also secure, portable, and scalable, because once you you put it in that Docker, it's more like a zip, like you are just zipping it, so it's much more like, in a condensed format, and it's quite scalable for anybody to use. So that brings us to Streamlit. So Streamlit is a Python framework designed to build interactive data apps or data products quickly. Now, Streamlit is not the only one. We also have other things, but like I said, I want us to pick one this thing to focus on. So let's just look at what Streamlit is. So if you looked at the original website of Streamlit, you will see now you can get it on streamlit.io. You see that they say turn your data scripts to shareable web apps in minutes, all in pure Python, no front-end experience required. So Streamlit takes away that lots of this thing for you, and you can have the free version, and you can also have the pro version where you pay to get some benefits you can get in the free version, like deploy with snowflakes for professionals. You can code in your browser or your favorite editor, and work with GitHub and all that. So yeah, you could see a lot of. Then there is the Streamlit playground. There is the gallery where you see the kind of apps that have been created. So let's see the kind of apps that they have created in the gallery. You can see Streamlit Extra, Roadmap, Pretty Maps. You can see GW, Quick View, 30-day Streamlit. You see so many apps. But let's go back to the home. I think we could see some examples if I'm not mistaken. So to use the Streamlit, it's very, very easy. You install the pep installed in your normal Python as your Anaconda or your CMD. You say pep install Streamlit, then you can say Streamlit hello. And once you say that, you run it, you see it to come up for you. So in order for you to have your first app, which if you have your system, we all could try that. You could quickly do this import Streamlit as st, and then import pandas as pd, then st.write, then of course you put the bracket because of the strings. You have my first app, hello world, and then you run it. And once you read your first data set, which is my data.csv, and then you plot a line chart or something, once you run it, you will see the app is going to pop up in your browser, and that will show you hello world, and and shows you the package you have. Now you can also build a lot of interactive platforms. You could play with things like this. You could be able to slide. It had this slider that you could be able to do that. And this is an example of an app. You can also browse files to load, and this is to pick between a pet, a dog or a cat, and all that. You could switch, or a bird. You could also switch to do that. You could see the calendars are there as well. It helps you to be able to do your deployment very easy. So you could easily just deploy the app, and then you connect it with GitHub, and I will talk about the GitHub shortly, how you could be able to also open the GitHub account to be able to use that. So you can see you have so many this, and you could see it's compatible with some different things like Becker, Alta, PyTorch, OpenCV, which is for images. This OpenCV is actually images. This PyTorch, remember, this is coming from the deep neural network, the TensorFlow, the Keras we just mentioned about, the Plotly, and the Matplotlib, the Pandas, the NumPy, the sklen. So you can see it's actually compatible with a lot of things. And now this is coming from so many people that are using the Streamlit. So you could go on and on and on to show how this Streamlit is being utilized by so many persons. Now, like I said, the basics of it, you could just import Streamlit as st, then st.title, my first data app, and then st.write, welcome to model deployment. Once you run it, you will see these things to come up. Anyway, we'll see that during the practical section. Now, there are so many features. This is an example of a web interface that was built on Streamlit. If you could actually see, you'd see how you have this different interactive dashboard, like what you see when you're working on Tableau. You see some of this kind of interface. So you could also do that easily in Streamlit by building multiple columns. So you could build multiple pages and they could display all in one place, or if you like, you can want them to display side by side. So you could upload the file, it will perform the analysis, and it will display the results for you. However, in order for you to use the Streamlit very effectively, you need to create some sort of a connection between the Streamlit and GitHub. Now, talking about GitHub, let's briefly look at what it means. GitHub is a platform where you'll be able to store your code, store your scripts, and it's just like it's the Facebook of developers. It's like the Facebook of code and scripts and all that. That's where people dump their scripts, dump their files. It's very, very good because it's one of the open science initiatives that want us to be able to share our codes so that other people could see it and reuse it. And also, you could also share in the data set that you use to generate it. Although, because of privacy concerns, sometimes people don't dump their data set there. They only just dump the scripts. And then they will tell you if you need the data, you could fill in some forms or something, then they can release the data set for you to be able to reuse them. Now, you can be able to build and ship your softwares on a single collaborative platform. Many other persons could also collaborate. And these days, the generative AI have invaded. I posted a video, I think it's from 2-3 days on Facebook, showing how the GitHub Copilot has, integrated. They have innovated these things where you could not just share code, but now you could even be able to use it to generate codes and all that. And I could show you also shortly about how these things are moving. So you could be able to share code, you could be able to plan, you can be able to collaborate, you can be able to automate, and it's all by by few things. You just to get a Git in your desktop, and then you could be able to push, you could be able to create branches and all that. And you could actually see that shortly. So the Streamlit Cloud, which is the free version, if you want to communicate with it, if you want to run your app on the cloud format or in the cloud space, you need to create a GitHub account. When you create a GitHub account, you need to create a repository. Then when you create that repository, you could take the codes you have already stored in that file in your local desktop, for example, or in the container. You could upload them to the GitHub. Then from the GitHub, you could now communicate with your Streamlit cloud. And that way, the code will be in GitHub, but at the same time, the deployment will be in the Streamlit cloud. So both the Streamlit and the GitHub, they will now be cross-talking with each other. And then at the end of the day, they could be running. And that way, you could also edit, you could change, you could improve your code on the GitHub. So any change you make, you push it. Once you make that change, you push it. You can update it on the GitHub, and then on the cloud, the deployment phase will reflect that change that you have made. So the both of them can be linked together. You link your repository when you deploy it on these platforms. Now, another thing again is Hugging Face Space. Also for public apps, you use Streamlit as the runtime to do that, like I said, for the deployment, but the codes and everything could be on the Hugging Face Space and all that. Although I haven't really used the Hugging Face, but I know of it. I've seen some nice apps from there, but I haven't really used it like that. So like I said, the GitHub is a hosting and sharing of code. using the Git, which is a sort of like a control system. Now, the beautiful thing about GitHub is that it helps you to track changes in your code. It helps you to collaborate with others. It helps you to publish your project. It helps you to deploy apps to Streamlit platform via the GitHub. So, like I said, it has so many advantages, and one of the advantages is that you can be able to track changes you made in your code. You can be able to also work with other team members, and it could keep your code safe in the cloud, and it could show off this, even in your CV. You could put your GitHub link so that anybody that wants to see what you have been doing, the person could easily just go back and then he or she will see the kind of things you have done. Now, there are so many terms that you could use on the GitHub, to do that. Like I said, in order for you to use the GitHub, just for now, you can go here, and I think I could share this in the group. You can copy it. Okay, I think Monday said he was logged out.
I've returned.
Okay. Sorry, I didn't check the. Okay, so I've posted the GitHub, so you could click on that and open an account on the GitHub. Once you click on this code that I just shared, you can come to anyway, just paste it on your browser. Then you will see where we have sign up for GitHub. So you click that one. Then you can see create free account. Now I already have a GitHub account, so I wouldn't want to, you see it said the username contain one or so. I wouldn't want to. So now you put your email that you want and the password, then a username. Now the username, you can put any username. I think I'm using a username, I think the master09 or something. So yeah, so you can see if you select the right username, already it said this is associated with an account, so I cannot be able to use this account, but I could use sorry, any account or something, but gmail.com. So you could put your own account, put the region, and then once you do that, you click on continue, and we get to see let me see, if I could use the email from the DataEdge Academy. Do this one. Good. So try to sign up now. To make sense, if you could do that. Let me say okay. So I need to use a very strong password. Continue. So once you click on the continue, you get this visualize puzzle. So they said you should find the image that has the price on the left held by the cloud in the machine on right. I don't understand this puzzle. Okay, so yeah, so you just click until you find this image that matches the one we have on the right. So this is the same image. Then you submit. Now it is been matched, so a code has been sent to my email, and I'll go to the email. This is now, yeah, so this is the code I've got. So I've copied the code. I'll go back to the GitHub, paste it, and now I've pasted. So now you say you have successfully created an account. Please sign in. So I will log out from my original account, for example, and will sign in with the new GitHub account I now have. So let's see. So back in this COVID. So let me try sign in. Good. So now I have signed in, and then the next thing I'm going to do is to go to a repository. You can see this is your profile. So under this your profile here, you can put your picture. You can put your picture, and also you can put once you click on edit, you can write a bio about yourself. You can also put a pronouns, the company that you can, if you like, you can use your university or the company you have, your location, and then you can also add your social media accounts like Twitter, LinkedIn, Facebook, and all that, where you want people to find you and they can be able to, you can save it. And then anytime you perform any operation, you will see it will always appear. You will see this dot showing that you actually did this. So in order for us to do this model deployment, you will need to go to repository, and then you can create a new one. So you now need to call the repository, let's say model deployment or something. Okay. So the name is available. If it doesn't have, you keep checking, and then you could. So here we talk about how to deploy machine learning models. Now, you also see the setting. Do you want it to be public for everybody to use? Do you want it to be private? That means it's only you that can have access to commit the repository. Do you also want to add a README file so people could be able to see what you've done, and so on and so forth? So once you are okay with that, you create the repository. So this will be your first repository that you have created. So now you have created a repo where you could. So the thing here is this: you can create this repo manually by doing this, or you could decide to use the CMD, which is, if you remember do you remember the CMD? So the Git also has a CMD. You could also have the GitHub desktop, which is basically the Git. I think I have it on my system. So the same whole thing. So you could easily just shift between your system if you like. Yeah. So you could yeah. So for me now, I have to sign in and all that. So you could continue with the browser, which is where we are now, or if you like, you could talk between the local platforms. So anyone you want, you could. So once you do that, you could commit, you could share, you could do all those things. And then another way you could do that, access the GitHub again, is by using the CMD. I think the CMD platforms here, although I think the Git itself have its own CMD. So from here, you can also be able to communicate with the Git. You could create repo, you could push, you could do any of those things also using this. But let me not complicate your life. Let's just focus on one thing at a time. As you grow, you could navigate this different approaches. So you could see you have just one branch, which is now you have created this model. So once we have trained from Jupyter Notebook, I'll show you guys how we could take these files to GitHub, and then from GitHub, we could now go to Stream. So now that you have done this one, now you need to create Streamlit Cloud. Also, you need to create an account with Streamlit. So Streamlit now, let's see how we can create an account with Streamlit. So again, go click on the Streamlit. So type the Streamlit again. I could give you the website. Let it just come up. I'll give it to you, and you could be able to there it pops out. Great. So I think it just pops out. I'll copy it again. I'll put it on the side. So again, this is the website. So you could click on it and get started. Remember. So once you click on this, you can see all the whole thing. So, but let's click on the free. You click on the free version. Great. So let me just close this. Now, once you are on the free version, you click on continue. Now you can see logged in. So if you don't have an account yet, so you need to sign up. So you click on sign up. Now you enter your first name. Let's see, our name here is DataEdge Academy, right? So okay, let me just take it here and put it like DataEdge Academy, for example. Now our email, I think, is learned. Let me copy it again here. Great. So we go back again, you paste your email, and then you send a code. So now the Streamlit code has been sent to us. So again, you see, this is the code again. So we copy the code. Now we go back again to the platform, you paste it. Right. So now we have created an account. Now they say, what is your functional area? So let's say data scientist, or do we say educator? Anyways, data scientist is fine. So you said my app is ready to be deployed or something. So any of the options that suit you. So now you can see we have created app. So once we have created a platform, so once you need to connect to GitHub. So you see, you need to connect them together. So if you want to connect it to GitHub, you will have to authorize it. Okay, you have to authorize it. So you want it to access this Don Marston 092. Remember, that's the DataEdge Academy ones we just created. So you authorize it now. So what that means is that you create a connection so the two of them can cross talk with each other. Okay. So now if we click this, which will come back later, you will see how we'll be able to do this deployment. So have you done all that? Once you have done that, we can move to the next thing. So this is how you can be able to set up your GitHub and also your Streamlit. So you set them to both of them up. So now once you are ready, if we are using the CFD platform, we can be able to make our Streamlit app whatsoever repo locally. After we have done that, we can use Git initiate. So this will connect us with the GitHub, and then we want to add that. So you need your username, and then you add the app that you have already created and all that to your GitHub. And I could show you all that, but again, like I said, I wouldn't want to complicate it because I really want to keep it simple so you'll be able to understand it basically. So having created your GitHub and also your Streamlit accounts, the best practices for you to do your deployment, you need the requirement.txt file. Now, the requirement.txt file has all the packages that you that you have used in the course of your training or your model training or whatever building. So you put all those dependency packages there. Sometimes you will need to specify the versions you used. Sometimes you don't need to, you just put the name of the package. Let's say you use pandas, you put pandas, you put sklearn, you used it as well, you put numpy, all the files you use, you need to put them in the requirement.txt files. Then handle exceptions and invalid input. Sometimes you need to put create a sort of a README file on how you could handle errors that may arise. Because remember, this model, you are not doing it for yourself, you're doing it for other people to use. Then you also have to make sure you avoid retraining the model in real time, because you have already done the training. So why have to go back doing the training? You just have to load it and make prediction. Load it, make prediction. Load the pre-trained models and then keep the apps in the modular and readable format. Remember, like I said, you are not the one using the apps. So if you are creating it for other people to use, don't make a lot of assumptions in your head, because your users may not have the knowledge in coding and all those things. So keep it simple. Keep it simple. Keep it simple. Don't forget. Make sure you keep it simple, because remember, even when you are selling products in the market, you need to make sure that you need to convince your customers enough that this product is going to bring maximum satisfaction to them when they purchase it. So that's how it is. Every day, people build millions of apps, if not in their millions. I don't think it's in thousands. I think it's in millions that people building, especially in the age of generative AI, where apps now is very easy. So if you don't keep it simple, nobody will use it. So make sure you make it very simple that people can be able to use it. Then secure sensitive information such as API keys, because anybody who has your API, the person could be able to use it against you. The person can use it for malicious purposes. So make sure you secure your API keys. And I could show you along the line on how you could be able to do that, to protect these things so it doesn't fall into the hands of wrong people. Remember, we've been talking about these cyber crimes that they saw a lot. So don't play with sensitive information such as that. Now, we have seen how we could connect our Streamlit to GitHub accounts, which we have done, and then we will see how this could be done effectively. So the hands-on section is example of this Streamlit in the industries of building explainable dashboards for fraud detections, health diagnostic apps, and customer segmentation visualization, then real-time social media sentiment tracking. So I think with that, we have come to the end of the theory section of this class.